Welcome to Space Drift. Please subscribe and hit the bell icon for more breaking updates. For millennia, humans have gazed at the stars and wondered, are we alone in the universe? This question has fueled our myths, our science, and our relentless curiosity. The search for extraterrestrial life is more than science. It's a quest to understand our place in the cosmos. We've sent rovers to Mars, probes to the edge of the solar system, and telescopes deep into space, all seeking answers. Each mission brings us closer to discovering whether life exists beyond Earth. Is life a rare accident, or a common outcome wherever conditions are right? Even finding simple microbes elsewhere would transform our understanding of biology and our place in the universe. So we keep searching, scanning radio waves, analyzing starlight, and building ever more powerful telescopes. The journey is long, but the potential discovery that we are not alone would change humanity forever. To answer these cosmic questions, we needed a new kind of eye, the James Webb Space Telescope. Launched in 2021, JWST's massive golden mirror captures faint infrared light from the universe's earliest days. It's not just a telescope, it's a time machine, revealing the first galaxies and probing the atmospheres of distant exoplanets. By analyzing starlight passing through exoplanet atmospheres, JWST can detect gases like water vapor and methane, potential signs of habitability. In just a short time, Webb has delivered breathtaking images and data, pushing the boundaries of our knowledge. Built by thousands worldwide, JWST is our silent emissary, nearly 1 million miles from Earth, gathering ancient cosmic light. It stands as the pinnacle of our scientific ambition, dedicated to understanding our place among the stars. Now, the James Webb Space Telescope has turned its gaze to our closest stellar neighbors, embarking on a mission that could redefine our understanding of the cosmos. With its powerful infrared eyes, JWST is able to peer deeper and with more clarity than any telescope before it, opening up new frontiers in the search for distant worlds. This time, its focus is on the Alpha Centauri system, just over 4 light-years away from Earth. Alpha Centauri is not just one star, but a trio. Alpha Centauri A, Alpha Centauri B, and the faint red dwarf Proxima Centauri, making it a complex and intriguing target for astronomers. In September 2025, astronomers announced a groundbreaking discovery. Webb had found evidence of a massive gas giant orbiting Alpha Centauri A, a world similar in mass to Saturn, but orbiting a sun-like star in our cosmic backyard. This marks a major milestone in exoplanet research. Using a sophisticated coronagraph to block the overwhelming glare of the star, Webb was able to reveal a faint, distant planet, 10,000 times dimmer than its host. This technique allows astronomers to spot planets that would otherwise be lost in the star's brilliance. When astronomers looked again, the planet had vanished from view, likely hidden by its highly elliptical orbit. Such orbits can cause planets to swing far from their star, making them visible only at certain times. This "now you see it, now you don't" behavior strengthens the case for a real planet, not a glitch or artifact in the data. The repeated appearance and disappearance is exactly what scientists would expect from a planet on a long looping path. If confirmed, this would be the closest exoplanet to its star ever directly imaged, a feat that challenges our understanding of how planets form and survive in binary star systems like Alpha Centauri, where gravitational forces are complex and dynamic. Remarkably, the planet orbits within the habitable zone, at a distance from its star comparable to the space between Mars and Jupiter in our own solar system. This region is where temperatures could allow for liquid water on any rocky moons or neighboring planets. While this gas giant itself isn't a candidate for life, its presence hints that smaller, rocky worlds could also be hiding nearby, perhaps even Earth-like planets waiting to be discovered by future observations. The discovery opens a thrilling new chapter in our search for life next door, inspiring astronomers and dreamers alike to imagine what other secrets the Alpha Centauri system might hold. Gas giants like Jupiter and Saturn are colossal swirling worlds of hydrogen and helium, beautiful but inhospitable. Their immense size and mesmerizing storms make them some of the most striking objects in our solar system, but beneath their colorful clouds lies a realm utterly alien to life as we know it. These planets lack solid surfaces, and their crushing, toxic atmospheres create extreme pressures and temperatures. Any spacecraft sent into their depths would be destroyed long before reaching a core, if one even exists. For life as we understand it, these are worlds of endless storms and impossible conditions. Yet, the discovery of a gas giant in a star's habitable zone is still exciting. It hints at the possibility of a complex planetary system, and raises new questions about what else might be orbiting nearby. Such planets could host large rocky moons, potentially with subsurface oceans like Europa or Enceladus in our solar system. These moons, shielded from harsh space by thick ice, may have hidden environments where life could take hold. These moons, heated by their planet's gravity and tidal forces, might offer the right conditions for life. Beneath their frozen crusts, liquid water could exist, warmed by internal energy, an essential ingredient for life. So, a gas giant in Alpha Centauri's habitable zone doesn't end our search, it expands it. It invites us to imagine new possibilities, and to look beyond the obvious for hidden worlds. It signals a system rich enough to build worlds, encouraging us to look for smaller companions, rocky planets or moons that might be more suitable for life. The gas giant is a signpost, not the destination, in our quest for life. Its presence points us toward new frontiers, guiding our search for habitable environments. Its presence means the system is dynamic and complex, full of possibilities. Each new discovery adds to the tapestry of worlds we have yet to explore. The real story may lie with the moons yet to be discovered, hidden worlds that could one day reveal the secrets of life beyond Earth. To appreciate this discovery, we need to understand Alpha Centauri, a triple star system. Alpha Centauri A and B are sun-like stars orbiting each other, while Proxima Centauri, a dim red dwarf, orbits farther out. From Earth, A and B appear as a single bright point, the third brightest star in our night sky. Proxima Centauri has already yielded at least 3 planets, including one in its habitable zone. Finding planets around the brighter A and B stars has been much harder. Their glare overwhelms faint planetary signals. Webb's advanced coronagraph finally allowed astronomers to peer past the glare and spot the gas giant. This system is a natural laboratory for testing our theories of planet formation in complex multi-star environments. The presence of a planet here suggests our models may need revision. Alpha Centauri challenges us to rethink what's possible in the universe. Much of the excitement about Alpha Centauri centers on Proxima B, discovered in 2016. This rocky world orbits the closest star to our Sun, making it a tantalizing neighbor in the vastness of space. Its discovery sparked a wave of hope and curiosity among astronomers and dreamers alike, as it represents a rare opportunity to study a potentially habitable planet just over 4 light-years away. Orbiting in its star's habitable zone, Proxima B is our closest known exoplanet and a prime target in the search for life. The habitable zone is the region around a star where temperatures might allow liquid water to exist, a key ingredient for life as we know it. This makes Proxima B especially intriguing, as it could possess the right conditions for biology to emerge. But being in the habitable zone doesn't guarantee habitability. Proxima Centauri is a volatile red dwarf, blasting its planets with intense radiation and powerful stellar flares. These outbursts could strip away atmospheres or make the surface hostile to life, challenging our hopes for a second Earth. Proxima B is likely tidally locked, with one side always facing the star, creating extreme conditions. One hemisphere bakes in perpetual daylight while the other is plunged into endless night. This stark contrast could make it difficult for life to thrive, but some scientists speculate that a narrow twilight zone might offer a more temperate environment. Scientists search for biosignatures, chemical hints of simple life, not advanced civilizations. They analyze the planet's atmosphere for gases like oxygen or methane, which could be produced by living organisms. Even a faint trace could be a sign that life has taken hold, however primitive it may be. So far, the universe remains silent, no signals, no city lights, no evidence of intelligence. Our telescopes and radio dishes have scanned the skies, but the cosmic silence persists, leaving us to wonder if we are truly alone. This great silence is the Fermi paradox. If life is common, why haven't we heard from anyone? The paradox challenges us to rethink our assumptions about life in the universe, and confronts us with the possibility that intelligent civilizations may be rare, short-lived, or simply too distant to detect. The new gas giant discovery broadens our search, reminding us that planetary systems are diverse and full of surprises. Each new world we find adds to our understanding of how planets form and evolve, and hints at the many possibilities for life beyond Earth. We must explore all types of stars and worlds, because we don't know where the next breakthrough will come. From small, dim red dwarfs to bright, massive stars, every system could hold secrets waiting to be uncovered. The search for life is far from over, it's just getting started. With every discovery, our sense of wonder grows, and the universe feels a little less silent. a little more full of possibility. The James Webb Space Telescope is just the beginning. Soon it will be joined by NASA's Nancy Grace Roman Space Telescope, launching in 2027. Roman's wide field of view will map the sky, discovering thousands of new exoplanets and complementing Webb's deep focus studies. With advanced coronagraphs, Roman will help confirm and characterize planets in bright, complex systems like Alpha Centauri. Together, Webb and Roman will form a powerful duo, building a comprehensive census of nearby worlds. Science advances through collaboration and accumulation of evidence, not single discoveries. The universe still holds countless secrets, and with each new tool, we get closer to answers our ancestors only dreamed of. What else is out there? The only way to know is to keep looking up.